Hi, I am Yogesh from Idea Design Solutions. Let's take a look at SOLIDWORKS simulation. For that, we will first open our part file. Here we will simulate the deformation due to load applied at handle. To do that, we will fix these faces and apply the forces acting on the handle at this face. Before that, make sure that the material data is applied to the part. Now we will proceed to enable the SOLIDWORKS simulation add-in and then create a new study. For this study we will select static, give it a name, and also enable 2D simplification. Alright, so here we get some options for 2D simplification, which are plane stress, plane strain, and axisymmetric. The plane stress option is used for thin geometries where one dimension is much smaller than the other two. The forces acting normal to the section plane must be negligible, resulting in zero stress normal to the section plane. Plane strain option is used for geometries where one dimension is much larger than the other two. And the axisymmetrical is used when the geometry, material properties, structural and thermal loads, fixtures, and contact conditions are symmetric about an axis. For this problem, we will select plane stress, then select our section plane, which will be the front plane. Then we will have to give a depth to our 2D model, for which we will use measure tool, to get the length of this edge. Input 8 mm in depth. We also get a nice preview of our 2D simplified model. Now just click on OK and we will get our 2D simplified model. Ensure that the material data is applied. Then we will add fixtures, select fixed geometry. Select the edges. Click on OK. To apply force, right-click on external loads, select force. Select the edge of the face. Change the unit to metric. Input the weight you want to apply. Click on OK. Then define the global mesh settings. Let it be slightly fine. Enable the mesh parameters. Here we get three options for mesh calculation, which are blended curvature mesh, and standard mesh. You can see that as we move the slider towards fine, the minimum size of the mesh also decrease. Now click on OK. After that we get our mesh. You can also see the details of mesh generated by right-clicking on mesh, and then selecting details. Now we can run the study by right-clicking the top component in the study tree. We will get our results as the simulation proceeds. So, now we got our solution. As you can see, it's still in 2D. Here, the deformation scale of the results is set to 30.64. You can also see the original position of the wrench by hovering the cursor over it. Here the max von Mises stress developed is around 125 megapascals, which is way below the calculated yield strength, that is 241 megapascals. Now let's take a look at the displacement plot. As we can see, the maximum displacement is at the ring portion, which is very obvious. Maximum displacement is around 0.6 mm. Now to edit the plot settings, select Edit Settings. Here we will change the deformation scale to true scale, then go to chart options. Change number format to general, it will change legend display. Also enable min and max annotations. Now to view the mesh alongside results, change boundary options to mesh. Now click on OK. The deformation scale is now set to 1. We can also arrange these annotations. We can also check the factor of safety plot. To do this, right-click on results and select Define FOS plot. Set the selection to all. Set an upper limit of FOS plot. Now click on Next. Click on Next. Set the selection to FOS distribution. Click on OK. Maximum FOS is now set to 3. And the minimum FOS that we get is 1.9, which is at the neck. We can also enable Show 3D to view the result in 3D. So that's it for this video. See you next time. Keep designing.